Hi guys, tonight we're going to take a look at scatterplots and line of best fit. And we'll talk about what these mean, but sometimes you'll see the word trend line in place of the line of best fit. So we're going to continue our look at linear equations and slope and y-intercept and continue to see how they are used in context. Okay, so to start off, just a couple of definitions of what a scatterplot is. So a scatterplot is what it sounds like. It's just a graph with a bunch of dots all over the place. So it's a graph that relates two sets of data, and we're still looking at the x-coordinate being the independent variable and the y-coordinate being the dependent variable. So scatterplots might look at the relationship between two things. So for example, is there a relationship between your height and your shoe size? Is there a relationship between the amount of time you study and the grade on your test? And all that relationship can be seen in what we call a scatterplot. And these examples down here are scatterplots. And again, here's our x, here's our y, and they're really just a bunch of dots all over the place. But if we look at how these dots relate to one another, this group of dots on this first graph is clustered in the middle like that. And if we look at the direction of the graph, it's going downhill. So we call this graph, it has a negative correlation. It's similar to slope. So this has a negative correlation because the dots are grouped together and it's in a decreasing pattern. The second graph, if you can't tell what direction or what pattern there are in the dots, and in this one we can't tell because they are just all over the place, this would have no correlation. There's no relationship between the two things that we're measuring. So for example, is there a relationship between shoe size and how much ice cream you eat? No, there isn't. So that's why the dots would end up all over the place like this. So our last graph, and again we look at the general direction of the clustering of the points. These are going uphill, so this one we would say, just like it looks like it has a positive slope, this one has a positive correlation. And correlation just means relationship. That's all it means. How are they related? That's what correlation means. So again, if the pattern is going downhill, it's going to have a negative correlation. If we can't decide what the pattern is, it's no correlation. And if the pattern is going uphill, just like a positive slope, it has a positive correlation. We don't have zero and undefined correlation. So the second thing we're going to look at is something called the line of best fit. And what I said in the beginning, the line of best fit is also known as the trend line. What direction is the data grouped together in? Is it going uphill or downhill? So the easiest way to draw in the line of best fit is to take a look at your pattern and see if you can box it in with dashes. So this pattern is going downhill, so I have dashes here, and I'm just going to kind of box it in with dashes there. The dashes will help us determine where our trend line goes, or our line of best fit. And by the way, this up here should say trend line. Sorry. So our trend line needs to go in between these two sets of dashes. It needs to go right down the middle of the data. It may or may not pass through points in the data, but our trend line needs to go through the center of the data. About half the points are above the line and half the points are below the line, and it ends up in the middle of these two dashed lines. And again, this one has negative correlation. On our second graph, if we can't decide where the trend line goes, this one does not get any trend line or any line of best fit. And I'm going to refer to it from now on as BF, the line of best fit. So go ahead and see if you can draw in the trend line for the third example. And again, just draw your dashes on the outside, the lower and the upper ranges of the data. And then your trend line needs to go through the center. It's kind of like the median in a road. It needs to go through the center of that data. And because we have a trend line, because it is a line, that means we can find slope and we can find y-intercept. And once we find slope and y-intercept, then we can write an equation for that trend line. And we can use that equation to make predictions about a certain set of data. So another thing I want to mention about correlation and trend lines, and again, trend line, another name for trend line is just line of best fit, is something called a correlation coefficient. So a trend line that shows the relationship between two sets of data most accurately is called, we call that again, another name for that is the line of best fit. And those two words are used interchangeably. Trend line and line of best fit mean the same thing. Later on next week, we're going to use the graphing calculator to find our line of best fit, but the graphing calculator calls it a linear regression. So we will have a day or two learning how to do all this on the graphing calculator. The graphing calculator also gives us something called a correlation coefficient. And again, we'll delve into that a little more deeply next week. And that correlation coefficient gives us a number, and it tells us, does the data, without graphing it, does it have a positive correlation, negative correlation, or no correlation? So if we look at this table right here, if I had a linear regression with a correlation coefficient that was very close to -1, that would mean it would have a negative correlation. If it's very close to +1, it'd have a positive correlation. And the closer it is to +1, the stronger the correlation. The closer it is to -1, the stronger the negative correlation. And then if we get close to 0, it has no correlation. But we'll come back to this again next week. I just want to introduce it to you here. R is also known as the correlation coefficient. We won't be using that in today's lesson, but it will come up again next week. Okay, we're going to take a look at this graph right here, and we're going to come up with a line of best fit. We're going to use something called the eyeball method. That means we're just going to eyeball in a line of best fit. Since it's a line, we can find the slope, we can find the y-intercept, and we can write an equation for that line. So the first thing we're going to do is on top and below the graph is draw in our dashed lines to kind of box it in. And then our line of best fit is going to go through the center of those dashed lines and hopefully through the center of our data. We'll fix that red line right there, through the center of our data. So that's what we did. We drew the line of best fit showing the general trend line. Obviously it's going uphill, so it has a positive correlation or a positive trend. Now we're going to choose 2 points on the line of best fit, and the points may not necessarily be the data points. So what 2 points do we want to choose? So let's highlight a couple points there. There aren't, my trend line didn't pass through 2 data points, but it got pretty close to this one right here, which is the point 44. And it also got pretty close. We can find another point. We could probably use this point right here. Now it's not one of the data points, but that's okay. We can still use it because it's on our trend line. And so that point, I believe, is 8, 8. Well, that works out nicely. So we're using this point right here, which is 4, 4, and we're using this point right here, which is 8, 8. And they are on the trend line. If our trend line had passed through any of these points right here, we could also use those. But again, we're using this line to make predictions. So part C, find the slope using these 2 points. So I'm going to go ahead and let you do that. Pause the video and check to see if your slope is correct. Okay, so I got a slope of 1 and it's positive. If you had used other points on the graph, we would have got a number that was maybe a little bit bigger or a little bit smaller than 1, but it would have been pretty close to 1. And again, we're calling this the eyeball method because we just kind of took a look at the graph, the scatter plot, to see where we wanted that trend line to go. Part D, we're going to use the slope in one of the points and substitute it into y equals mx plus b. So this is what we did in class the other day when we were reviewing for the quiz. The slope was 1. It doesn't matter which point you pick. I'm going to pick this point right here where x is equal to 8 and y is equal to 8. And now we have to find out what b is. So we're going to solve for b. So our equation for slope-intercept form is y equals mx plus b. We're going to plug in 8 for y. The slope is 1. We're going to plug in 8 for x plus b. And we get 8 equals 8 plus b. So our y-intercept has to be 0. So then we're going to write that equation. Y equals 1x plus 0. We can also write that as y equals x. If you look at the graph over here, my line doesn't go through 0, but again, that's because we're estimating where this trend line goes. If we had picked other points, like I said, our slope may not have been 1 and our y-intercept may not have been 0, but it would have been really, really close. Okay, so now it's your turn. Given the graph and the line of best fit, write the equation of the trend line. So again, the trend line is going through the data, through the center of the data. Look back over your notes, pick 2 points, find the slope, use that slope in one of your points to find the y-intercept. And in the number 2, free response for the scatter plot below, what is the correlation? So it either has a negative correlation, a positive correlation, and if you can't tell, it has no correlation. Be sure to enter your answers in the Google form.